Alright, this video is going to be some quick practice over how to do units and measurement conversion and also density problems. So the first one says a solid piece of aluminum has a mass of 178 ounces. So I know that I have 178 ounces that I'm going to need to use to start with on my dimensional analysis T. Alright. So the first thing is, whatever you're given, it's going to go in this top spot on your dimensional analysis. They want us to tell them how many milligrams does that piece of metal weigh. Well, the first thing that I know is that 1 ounce is 28.3495 grams. So although this conversion factor gets me to grams and away from ounces, I'm going to have to continue to do a little bit more because they want to know how many milligrams. Okay, so let's start by getting rid of ounces. So since ounces is on the top here, I'm going to put ounces on the bottom and I'm going to put grams on the top because anything that's diagonal like this is going to cancel. Now, I have to put what is in this conversion factor given to me. Right? I can't just put the 28.3495 on the bottom because that's not what equals what? 1 ounce equals 28.3495 grams. So you have to keep these numbers with the units that they are within that dimensional analysis conversion factor. So I'm going to put a 1 down here, 1 ounce, and that's equal to 28.3495 grams. My ounces cancel and we're in grams, but we can't be finished yet because they want to know how many milligrams does the metal weigh. So what I need to do at this point is remember the conversions that you were required to memorize for our unit test. And so the ones we had to memorize are in a table in your notes that looks somewhat like this. And remember, we had to remember from giga 10 to the, ninth, all the way down to pico 10 to the negative 12th. You can't see them very well here, so I'm going to zoom in just a minute. But these are the conversion factors that we need to memorize from giga all the way down to pico. All right? Now, remember that when we talk about this, we're going to write it 1 times 10 to the 9th for gigameter. But this one's asking us about milligrams. And so if you look here, a milligram is equal to 1 times 10 to the negative 3rd grams. So I'm going to go ahead and use that conversion factor and say that 1 times 10 to the negative 3 grams is equal to 1 milligram. And the reason why I put grams on the bottom is again because they cancel diagonally. So to solve this, we're going to do 178 times 28.3495 equals, and then divided by 1 times 10 to the negative 3. So on my calculator, I'm going to do 178 times 28.3495 equals, and then I'm going to say divided by, and I want you guys to watch me do it, 1 times 10 to the negative 3rd. 1 times 10 is that EE button to the negative 3rd equals. And there's my answer right there. So 178 ounces of aluminum is going to be equal to 5,046,211 milligrams. If I asked you guys to put this into scientific notation, I would need to have a digit between 1 and 9 first, followed by a decimal, and then write out the rest of the digits. So that would be 5.046211 times 10, and I need to write the exponent right here. That's basically going to tell how many times did I move this decimal place over until I reach the end of my whole number. So I would move it from 5.0, so this area here, I would move it 1, 2, 3, 4, 5, 6 spots. And since that's a huge number, it's way greater than 1, my exponent is going to be a positive 6. If it was a very tiny number, less than 1, with zeros preceding it, then my exponent would be a negative 6. All right, let's do another one. This dimensional analysis is going to require us to do 2 different parts of the problem, and we're going to choose to do whichever one, but we have to do them one at a time. So this is for Michael Rickley. He's a swimmer. So if Michael is going to swim 2,100 meters per day, what is this in miles per week? So the first thing that I'm going to do is write down what I'm given, 2,100 meters per day. And again, you pick where you want to start. You can either first go meters to miles, or you can go days to weeks. So I'm going to go ahead and do days per weeks first, and then I'll go back and do meters to miles. So the first thing I'm going to do is, this is over 1 day. 2,100 meters in 1 day is what he can swim. So what I'm going to say is, I know that to get to weeks, there are 7 days in 1 week. Again, I put days on top because if it is diagonal with the days on the bottom, then it's going to cancel and become 1, which essentially gets rid of it. So now I know how many meters per week Michael swims, but I need to know how many miles per week he swims. So what I would do here is I would first go from meters to kilometers, right? So if I've got 2,100 meters here, I need to get to kilometers first, then I can go to miles. So what is the conversion between meters and kilometers? Again, that's back on the chart. And so I know that 1 kilometer is equal to 1 times 10 to the 3rd meters. Another way of saying that is 1,000 meters. When meters and meters are diagonal, they cancel. And now my answer is in kilometers per week. Last step, let's turn those kilometers into miles. Using the conversion factor right here, 1 kilometer is equal to 0.621 miles. I'm going to put my kilometer on the bottom because I want it to cancel, and it's equivalent to 0.621 miles. Kilometers cancel, and my final answer is going to be in miles per week. And that's exactly what they were asking of us. So now to solve the problem, I'm going to take 2,100 times 7 times 0.621 equals, and I'm going to divide by what's on the bottom, divided by 1 times 10 to the 3rd. Remember, that's 1 second comma, or E3. And the final answer is Michael swims 9.1287, and that's going to be miles per week. Final answer. We don't need to put it in scientific notation because the number is a relatively small whole number. All right, I mean, it does have a decimal, but you know what I'm saying. It's a relatively small first number. Okay, let's do number 3. Number 3 is about density. So density is a formula that you need to memorize for the quiz. D equals M over V. Don't forget the magic triangle. D equals M over V. I'll be using the magic triangle here for the next couple of problems. I encourage you to use it because it's quick and easy. So it says rock salt has a density of 2.18 grams per centimeter cubed. What would the volume be? So this is what I'm looking for. It says, what would the volume be? So I'm looking for V. If I had 4.8 grams of my sample of rock salt. So I know that grams measures mass. So I know my mass is 4.8 grams. I know my density is equal to 2.18 grams per centimeter cubed. And now I just need to know, how do I put it into this formula so that we can get by itself the V. So I'm looking for V. If I'm looking for V, I'm going to use my finger to cover it up, and it tells me to take M and divide it by D. So I'm going to take my mass, 4.8 grams. I'm going to divide it by my density, 2.18 grams per centimeter cubed. These grams cancel, and centimeter cubed comes up. So my answer is 4.8 divided by 2.18, and I get 2.20. And again, centimeters cubed would be my unit for volume. Remember that 1 centimeter cubed is equivalent to 1 milliliter as well. So I could say that my volume is 2.20 milliliters. All right? Okay, let's go ahead and do 2 more problems. Number 4 that I have for you guys is another density problem. And then number 5 is going to be density with some converting of units. So a piece of lead placed into a graduated cylinder of water, and the water level rises 1.5 milliliters. This is called displacement. So the displacement is equal to 1.5 milliliters, and that's the same thing as the volume of the lead. All right, that's the volume of the lead. So I know that it has a density of 11.34 grams per centimeter cubed. So we're looking for what was the mass. We know V, we know D, we're looking for M. Magic triangle to the rescue. Density is mass over volume. Cover up what you are looking for. We're looking for mass, so I cover it up, and it says do density times volume. So I'm going to take my density, 11.34 grams per centimeter cubed, and I'm going to multiply it by my volume of 1.5. Now remember that 1.5 milliliters is the same thing as 1.5 centimeters cubed. So I could go ahead and change this to centimeters cubed, because why? I need my units to be alike before I plug it into a formula. So let's take 11.34 and multiply it times 1.5. And I get 17.01. And since this is going to be mass and my centimeters cubed cancels, my unit is going to be in grams. All right, our final problem for review says gold has a density of 19.3 centimeters grams per centimeter cubed. If a piece of gold has a mass of 2,850 centigrams, what is the volume? Well, if I look at my magic triangle, density is mass over volume. Covering up the volume, let's do mass divided by density. So I can't do centigrams divided by grams per centimeter cubed. These have to be in the same unit. So I'm first going to need to convert centigrams to grams. So I'm going to start with what I have, 2850 centigrams. And I need to memorize the conversion for centi. Centi is 1 times 10 to the negative 2. So that always goes with the base unit of gram, meter, or liter. So I'm going to always say 1 centigram, and then I'm going to say is equal to 1 times 10 to the negative 2 grams. Centigrams cancel, and my answer is now in grams. So take 2850 times 1 times 10 to the negative 2, and you get 28.5 grams. So I'm going to record that on my paper, 28.5 grams. Now that this is in the same unit as this, I can go ahead and follow through with V equals M divided by D. Again, cover up V. It's equal to M divided by D. So let's take our mass, 28.5 grams, divide it by the density, 19.3 grams per centimeter cubed. Your grams cancel, and our answer is going to be in centimeters cubed. 28.5 divided by 19.3, I get 1.476. I'm going to round that up to 1.48. 1.48, and then again, since we're looking for volume, and we're dealing with centimeters cubed here as the volume, I would report my answer as 1.48 centimeters cubed.